Okay, so the correct answer is 4. So why is it just 4? Why isn't it 6?
Because the two ending zeros are uncertain. We don't know exactly what those numbers are.
That's right. Because we don't have a decimal there, these two zeros here are uncertain. So these are the only ones that are going to be significant. So these are called lagging zeros. Okay, so what about the next number?
Nine.
That's 2, 4, 6, 8, 9. 9 sig figs. That's correct. What about the next one?
4.
4 sig figs. Everybody agree? That is correct. Only these are significant. These are just placeholders. So those are leading zeros. Okay, what about the next number?
Is it just 3?
4?
Nope.
Oh.
It's not 4. It's not 3.
Is it 9?
Not 9.
6?
It is 6. These 6 are significant. So if there's a decimal there, numbers that are trailing your non-zero numbers become significant, because you're saying, you're taking the time to actually write those zeros out. You're telling the reader that I am sure about these numbers. Otherwise, you wouldn't write them, right? Okay, what about this one here?
1.
1. And this last one?
3?
Nope.
Four.
Somebody said it under their breath. They said 4.
4.
Correct answer is 4. Yes. So because we put this decimal here, we're telling the reader or the person that we're sending the data to, we're saying this zero is significant. Otherwise, I wouldn't have put the decimal there. I would have just written it. And then this guy would only have 3. Okay. Good. Okay. So let's see. Okay, so let's see. Let's say I wanted you to write these numbers in three significant figures. Okay. So if I want to write this so that there are 3 significant figures, what would be the answer to the first one?
Would it just be 105?
Now remember to put our placeholders, because it's 105 equal to 105,000.
No.
Okay, so then the answer
Would
would
it-
be okay, or we could have wrote it as 1.05 times 10 to the what?
5.
Okay.
10 to the 5th.
That's correct. Okay, what about the next number? Okay, somebody gonna volunteer, or am I gonna have to volunteer somebody?
156,000.
You mean 1 million, right?
Oh yeah.
1,560,000. Or 1.56 times 10 to the what?
6.
Okay. Okay, the next number. You want to help me out with it, Nadine? Or sorry, Nadia? Anyone?
Would it be 2.0 times 10 to the -4th?
So would that be 3 significant figures?
Would it be like, no, but 2.00?
There we go. 2.00. Yes.
Oh, okay. Okay.
Good job, Vanessa.
Thank you.
Mari, you want to help me out with the next one?
Would it be 2.35 to times 10 to the -4? Fourth.
Okay. That is correct. Okay. Anyone for the next one? Alan?
It stays the same.
It stays the same. Okay. What about the last
Why
one?
does it, I'm sorry, Professor, why does it stay the same?
It stays the same because it only has one significant figure. So you can't give it more significant figures if it only has one significant figure.
Oh, okay.
It's kind of like, I can say I'm a millionaire, but if I only have $1 to my name, am I really a millionaire?
Got it.
Okay, so the last one.
(1.06 times 10 to the 4th power).
That is correct. Piece of cake? Yeah? Okay, you guys ready for the next part? So you should expect to see this on the exam since we're taking the time to go over it. And that reminds me. Okay, so let's do addition and subtraction. Okay, so how would I go about doing this?
You start drawing lines that distinguish where the significant numbers end versus the uncertain numbers.
Okay, so the very first number, where does the significant number end and the uncertainty start?
Between the 3 and the 0.
Okay. Okay, what about the next number?
After the decimal with the 3 zeros.
So right here.
Yes.
The next number?
After the decimal with the 2 zeros.
And the last number.
After the 1.
Okay, so let's go ahead and add it up. So we have, oh. So where am I going to draw the line to decide whether I'm going to round up or am I going to round down?
The line to the farthest to the left.
Okay. So this line here, the green line.
Yes.
Okay. Okay. Is my math okay? Okay, so we're going to use which number to determine?
3 after the green line.
3 after the green line. Okay, so 3. Are we going to round up or are we going to leave it alone?
We're going to leave it alone.
Okay, so our answer is going to be seven, 2, 27, a million. What is it? So if we're going to leave it alone, what is it going to be our number? What's going to be left? Anyone?
Basically would be the same thing that you have written down there already, no? The product. The
So it'll be 3, 1.
3, 8,
and-
4, 1.
No, we're going to put zeros there, right? Because this is all uncertain. Anything after that line is considered to be uncertain. So we want to put zeros there. So we use this number to decide whether we round up or we leave these first two numbers alone, right? Or we leave that number next to it alone. And then after that, we just plug in our zeros. So that's going to be our very last answer. Okay, our very last answer. This is going to be our answer. Questions? Do you guys get it?
Yes.
Okay, good. So I can move on? Or do you want to try one more?
One more.
One more.
Okay. Good. So where would I draw the lines for the first number? Let's get us all lined up.
Would it be at the end of the 25? Like the 5?
Okay. Okay, what about the next number?
After the 1.
Are you sure?
No, I'm thinking about it right now. Wait.
After the last 0.
Yeah.
After the last 0.
I didn't see the decimal. I was like, wait.
Okay, and the next number?
After the 1.
After the 1. Okay. So which one are we going to use? The first line, the second, or the third line?
The green line.
The green line. Okay, so the first one. Oops. Okay, so we have okay. So are we going to round up or round down? Or
Round down because you don't have anything after the 5.
that is correct.
Down.
So our answer is going to be piece of cake.
Yes.
Okay. Okay, so multiplication and division. You guys ready? No questions? No concerns? Okay. So let's say we have this number. Okay. So when we're doing multiplication and division, or multiplication or division, we're going to take the ones that have the smallest number of significant figures, and that's going to be your answer. So how many sig figs does this first number have?
1.
4.
4.
4.
4 sig figs. Okay, what about this number here?
1.
1.
Okay. What about this number here?
3.
3.
And this number here?
4.
4.
Okay, so we'll go ahead and multiply it across. So what do you guys get? What's this?
Is it 48? Oh, you mean
Yes.
multiply those, not the
Not the numbers down here.
Kidding.
Not the number sig figs. Calculator. That's how bad it is. Well,
You
What do
get
you guys?
0.04.
So you get. How many sig figs should I have?
Four?
What
One.
is the smallest number?
Oh, the smallest.
1. So this will be my answer. Piece of cake?
Yeah.
Okay, so let's try another. So what are we going to do first?
Is that a division symbol after the 40.0 or should it be multiplication?
It's division.
Oh.
Is that better?
Yeah, thank you.
No problem. Okay, so what are we going to do first?
We calculate how many significant figures are per number.
Okay. How
4.
many do we have here? Here,
2,
here,
3,
and here.
4.
Okay, so my answer is going to have how many sig figs?
2.
Okay. So what do you guys get for your answer?
$2,400.
Okay. Piece of cake?
Yeah.
And is it 2 sig figs?
Yes.
Okay. Okay. So what happens when we have both addition and subtraction?
You do PEMDAS?
That's right. Okay, so let's try one out. Well, actually, let's do this one here. We'll keep that same number, and then we'll add on to it. Okay. So we know what we're getting for what's in parentheses, right? So it'll be that number, even after our sig figs. Okay, so where would I draw my lines? For the first number?
In between the
Go ahead. You both started and then you both stopped.
in between the 4 and the 0.
Okay. And then the second number?
After the 5.
Okay, so which line am I going to use?
The first line?
Okay. And my answer is going to be is it right? Should be 3, right?
Isn't it gonna be 450?
You're correct. See, you got to keep me on my toes. Okay, so 450. The final answer. How many sig figs should it have? And what will I round it to? Or will I round it?
Aren't we keeping 2 sig figs?
2 sig figs?
Then
So I'm not going to round it. I'm going to leave it alone. Is that what you're telling me?
I think you would leave it.
So I'm just going to leave it at 450.
I don't think so. I think that you're gonna take it and make it 400.
So you say you don't think so. So what am I going to use? Which number am I going to use to determine what I'm going to round to?
5 after the line that you drew.
Okay, so right here. Okay, so am I going to round up or am I going to leave it alone?
You're gonna round down.
Okay, so my answer is going to be
300. 400.
400. Yeah, we're not going to take away from it. We're just going to drop this to a 0, right? So that would be my answer. And how many sig figs is that?
One.
Okay. Piece of cake?
But why would it only be 1 sig fig if I thought we had 2?
We had 2 for the multiplication, right? So we've taken care of the multiplication part right here. So that isn't going to change. So we're going to use that number that we've gotten, and we've already done the significant figures on it already. And then it's being subtracted by this number. Well, there's still this uncertainty associated with it, right? And so we only end up with 1 because that's all we have left in that 100 spot. If we had more left over here, we could end up with 2, but we don't. So we're limited by what we have left. Do you see that?
I get what you're saying, but I don't understand because when we were writing out the sig figs per number, we found that 2 was the smallest one. So then why?
But that only applies for multiplication and division.
Oh,
right. So we also have, so that was taken care of with this part. We had our 2 sig figs here.
okay.
And then with addition and subtraction, it's going to be a different rule, right? Now we look at in terms of the uncertainty, which has the largest number of uncertainty. Well, this guy has more uncertainty than this guy. And then after we do our subtraction, these are the numbers that are left.
Mm-hmm.
So we can't add certainty to something that's already uncertain. You know, these numbers are uncertain, so we can't add certainty to it. Do you get that?
Not really. I mean, I get how you did everything. I guess. I guess so. Then when we write out the sig figs per number, that's just like the preliminary, like at the very beginning.
But no, when we write out the sig figs per number, we only write out the sig figs per number for multiplication, right? So you have to do each step independently. You can't do it as if you can't intermingle addition and subtraction. When you do PEMDAS, do I just go ahead and I'm going to subtract it from here? When I do PEMDAS, do I do that?
No.
No, right? I do what's in the parentheses first. Do you understand?
Yeah.
So what you're doing in terms of your rule is, for rules, you have to do your multiplication rule. Did we not do our multiplication rule?
Yeah.
And so we have already taken care of our multiplication rule, so we can check that one off. And then we have to do our addition and subtraction rule. Didn't we just do our addition and subtraction rule right here?
Yeah.
So now we can check that off. At the end, this is the number that we have. So we have that line, we have to decide, are we going to round up? Or are we going to leave it alone? Well, the line tells me, and this is a 5 exactly with nothing following it. So that means I'm going to leave it alone. So it's just going to be 400. Do you see it now?
Yeah, I got it.
Yeah. Okay. Any other questions? Okay. So are you certain or are you uncertain? How many sig figs do you have in terms of that? Your answers here. Okay, you missed my bad joke. Never mind. It's horrible. You guys don't even laugh at the worst.
Because we're still uncertain.
Yeah, I see. Okay, so you ready to move on? You want to see where let's see where we're at. I have so many windows open. Chapters 3. Okay, so let's test those skills. Now you've been blessed with a lot of information. We'll see how much of it you guys retain.
Okay.
Okay, so okay, how many sig figs for that first number?
Three.
Okay, and the next number?
2.
Okay, piece of cake?
Yeah.
Okay, so let's say we have, let me read this. A student weighs a beaker and 4 different chemicals using different balances. The individual masses and their sums are, for the beaker, 319.5 grams. For the chemical A, it's 20.460 grams. For chemical B, it's 0.0639 grams. For chemical C, it's 45.642 grams. And for chemical D, it's 4.173 grams. Okay, so if we add them up, it's going to equal 389.8389 grams. Okay, so where would I draw my lines? For the first number,
After the 5.
okay. Second number,
After the last 0.
Our third number.
After the 9.
Our fourth number.
After the 2.
And our very last number.
After the 3.
Boy, you know, it's really great to have a class of one person. You know what? I think I'm just going to give that one person an A. You don't even have to come to class anymore. I'm just going to give you an A right now. Nobody will know since nobody else is here, right?
Periodically.
Periodically. Okay. Okay, so which line am I going to use? The first one being the red. The second one being the one that has multiple colors. Or the third one being the purple.
The red line.
The first one.
I heard the first one. Did somebody
The
say the
first
third one? The
First.
first one. Okay. So we're going to use the first one. Oops. Without erasing all the numbers. Okay, I still can't manage to do it without erasing all the numbers. Okay, so the first one. So we have that 3. So what are we going to do with that 3 since it's on the other side of the line?
Make it a 0.
Are we going to make it a 0? Or we're just not going to worry about it? So our final answer is going to be what? Because you said make it a 0. So I'm going to make it a 0. So it's going to be 389.089. Is that going to be my answer? Oops.
No.
The rest of them become zeros because isn't it the rounding factor or something?
Okay. It's my rounding factor. So the rest of these guys become 0. So am I going to put those zeros there?
Yeah.
Well, no, because they're
Or
Ah, so it's just going to be 3.89.8. So a total of 4 significant figures. That is correct. Piece of cake. So we use this number to determine whether we round up. So if we don't round up, we just take that number that's there, 389.8. And this all here is uncertain. So we leave that stuff alone. We drop it. Okay? Questions? Concerns? Cash? Credit?
would we so when we get that answer, could we put it in scientific notation as well, or do we just leave it like that since
Yeah.
it's grams?
You can leave it like this, or you could put it in scientific notation.
Oh, okay.
But you know, what's the benefit of putting in scientific? These are few numbers, it's not going to kill you, right?
Yeah. Yeah.
Usually when we have like a lot of zeros is when we want to use those scientific notation.
Okay.
Usually. Or when we want to make sure that you know how many significant figures we're working with. Right. Okay, so let's move on. Okay, so clear. Okay, so if the mass of 1.000 liters of gas is 1.436 grams, what is the mass of 0.0573 liters of gas? Stop yawning. It's too early. So where am I going to start?
With 1.000.
I'm going to start with 1.000. Okay. So I'm going to ask you a question. I want you to think about it. It says, if the mass of 1.000 liters of gas is 1.436 grams, is that an equivalency?
Mm-hmm.
So would I start with my equivalency, or would I start with what's given to me? Because I'm basically saying that this is 1.000 liters is equal to, because that is the same thing as saying equal to 1.436 grams. And that means that's an equivalency, right?
Mm-hmm.
Yeah, no, maybe.
Yeah.
So we normally start off with what's given to us normally, right?
Right.
Okay, so what is given to us?
The other mass.
This is a mass. Liters is a mass.
Oh.
We start off
Because it
with the
says-
amount of gas we have.
So is liters a mass? That's what I'm asking. And also, is it an amount or is it a volume?
An amount?
It's an amount. So liters is an amount. It's not a volume.
Volume.
So liters is a volume. Mass is weighed in grams or pounds. So you want to make sure you understand that and get that down now, because otherwise you're going to get destroyed in this class. So you want to definitely know the difference between volume and mass. Okay. And it says, what is the mass? That means that's what we're looking for. We want the mass, right? So we have 0.0573 liters. And you guys know the difference between liters, right? Volume of water, right? It's not how much that weighs. When we want to ask how much something weighs, we want pounds or grams or mass. We want the mass, okay? So we're starting with the volume. How am I going to use this? So I have this nice equivalency. How am I going to use that nice equivalency?
Put the 1.00 liters right next to the other liters. Volume.
Okay, so I'm going to ask you another question. I put 1.00 liters right next to the other liters. So are they going to cancel each other out?
Oh, no.
That's going to give me liter squared. Do I want liter squared?
No.
Aren't I trying to get rid of liters? So,
On the
so
bottom?
where would I put it? I put it at the bottom?
Yeah.
Okay. Okay, so then that means what's going to go on top?
The, how do you
The
say
grams.
grams?
1.436 grams.
Okay. So then that means liters cancel out. Is that right? Liter over
Mhm.
liter. So if I have L over L, what is that going to equal to?
1.
1. Okay, so it cancels out, right? So at the end of the day, we just multiply across. Sucks when you don't have your calculator with you. Or my calculator's battery is dead, so I have to go get some more batteries. So who's going to do the math for me?
It's 0.0822828.
Okay, so how many sig figs do we have for that first one? First
3.
number here, we have 3 sig figs. What about here?
4.
And then here?
Four.
Would it be 1?
Nope, it's because we have that 0.000, right? Remember, if we take the time to put that decimal point and all those zeros afterwards, they're going to be significant. Right? Because that normally, if it was only 1, we just put 1 number, right?
Mm-hmm.
Okay, so how many sig figs should my answer have?
4.
3.
3?
3, that's
Oh,
right, because
3,
3
yeah.
is the smallest, yes?
Mm-hmm. Yes.
Okay, so my answer should be
0.8. 0.08.
2, 3 at the end.
2, 3, that's correct. So that would be 3 sig figs
Grams.
and grams. Thank you for units, because that would be a minus a point. Okay, piece of cake?
Mm-hmm.
Okay, so a couple of things before we keep going. So don't get discouraged if you get stuff wrong, because the whole purpose of us being here is to learn. And if you know everything, then it defeats the purpose, right? Then you don't really need me, and I could just come in and do my hair or whatever, and you guys could just, show up if you want to show up and stuff like that. The whole purpose of it is learning, and the best way of learning is by making mistakes, because it helps. You may think it's only hurting you, right, by you not getting it, but by you making mistakes, it allows us to go over the material in a little more detail, so that you're able to get it, okay? And it also helps me to say, hey, I need to think about a better way of explaining this, okay? So you're helping me out a lot. So it's okay to get things wrong, and you definitely want to get things wrong in lecture than getting things wrong on a test, right?
Yeah.
Yeah. So keep going, right? Even if you don't get it right, keep going. Don't let it discourage you, and keep answering, because then it, like I said, it helps me, it helps me just as much as it helps you. Okay, so let's keep going. Oops. Okay, so you guys are feeling comfortable with sig figs and the rules and how to apply them? A little bit?
Mm-hmm.
There's a lot of them on the homework, so make sure you guys are working on that. Okay, so Sky asked me if I can go over the homework problems. So yeah, I can go over some of the problems, but I want to go make sure we get to a certain point today, so then that way we're not falling behind, okay?
Okay.
Okay, so let's talk about the metric system and the United States customary system. So the United States customary system is a fancy way of saying the empirical system. We don't want to sit there and tell everybody that we still rely on the king's measurements, the size of the king's foot and the size of his pinky and all of that stuff. And that's basically where the inch came from and the foot came from and all of that, okay? So we need to be able to convert from the metric system to the US customary system and vice versa. You need to be able to go both ways, right? So you need to remember length. Length is inches, and that's going to be equal to 2.54 centimeters. Mass, which is weight, or what we refer pounds, 1 pound, is going to be equal to 453.59237 grams. And volume is going to be in gallons. So we have 1 gallon is going to be equal to 3.785411784 liters. Now, this here is basically our US customary system. So you guys know how many inches are in a foot, 1 foot. 74? Are anybody there?
12.
12.
Yeah.
Okay, so we have 12 inches in a foot. So we have 3 feet in a yard. We have 5,280 feet in a mile. So mass, 1 pound, we know is going to be 16 ounces. Volume, 1 quart is going to be equal to 32 fluid ounces. Or we could, 1 gallon is going to be equal to 4 quarts. Okay, so let's see those skills. So it says a soft drink manufacturer is converting from USCS units to metric units. If the quart bottle initially is to remain the same volume, what number of milliliters should be printed on the label? Two, right? So where am I going to start? People. Sky, tell me, where should I start, Sky? You can type it in the chat window if you don't want to talk. Or Alan. Okay, neither of you guys know? Nadia, are you there?
Yeah, I'm here.
Okay, do you want to help me out?
Yeah.
Okay, so where should we start? What is given to us? Let's go through the problem again. It says, a soft drink manufacturer is converting from USCS to the metric units to the metric units. If the quart bottle initially is to remain at the same volume, what is the number of milliliters? What number of milliliters should be printed on the label? So if the quart bottle, so what are we starting off with? How about that? A quart bottle. So we have how many quarts here in a quart bottle? Or the quart bottle?
Is it 1?
Okay, so we're going to be starting off with 1. Okay, so we have 1 quart. Okay, so that's my given. And what do I want?
Milliliters?
I want milliliters. Okay, so how many quarts are in a gallon?
4.
4.
Okay, so we know that there's 4 quarts in a gallon. How many gallons are in a liter? Or how many liters, let's say, how many liters are in a gallon?
3.785.
Okay. So 1 gallon equals 3.785 liters. And how many liters are in a milliliter?
1,000.
So 1,000, I'm sorry, 1 liter equals 1,000 milliliters. There we go. Is that correct? Say it backwards. Okay, so we got 3 equivalencies to work with. So I have quarts here up top. So what am I going to put at the bottom to get rid of my quarts?
The
Four
four
quarts.
quarts.
Okay, so that means my 1 gallon is going to go on top. Okay, now I have 1 gallon on top. What am I going to do to get rid of that 1 gallon?
You put 1 gallon at the bottom.
Okay. So then that means what's going to go on top next?
3.785 liters.
Okay, so I have So I have 3.785 liters up top. So how am I going to get rid of liters and get milliliters?
You're right. 1 liter at the bottom. And on top, it's 1,000 milliliters.
Okay. Okay, so then that's going to give me my answer in milliliters. So, oh my. Okay, so. So we ended up with okay. So that would be my answers. My answer. So if I was doing sig figs, how many sig figs should I have? If I started off with 1.0, say 1.00.
You just need 1 sig fig.
1 sig fig?
3.
3
Oh.
sig figs?
3.
So I heard 3 and I heard 1. So 3 sig figs would be this. And 1 sig figs, it would be, so why would it be 1 sig fig? Or why would it be 3 sig figs?
If we started with 1.00, there's 3 significant numbers in that.
Okay, but what about our conversions? Do we count those?
Oh, yeah.
Actually, you're right. We don't count the conversions. So the stuff that's on your conversion sheet, we're not going to count. right? Because those numbers are quote considered to be exact. So it's kind of like saying 1.0000000000000. But we just write them down simply. So if you have conversions, you don't count your conversions. Okay, but like in the last one, we had an equivalency, right? We're going to count that in that situation. You see the distinction between the two? It's minor, but it's a little distinction. Conversions are kind of like, oh, so this is the common. So in that case, you only want to start off with the number of sig figs that you're starting off with in this case, because these are just conversions. I know, all these little rules, huh? So the correct answer would be that if we started off with 1.00. Although our problem didn't necessarily say that either. It actually just says a quart. So I'd probably just put 1.
Unless we had our conversions actually in the question, right? Then we would calculate them in there.
Well, no, even if they were within the question, right? They would still, because they're conversions, they're not. So if it's an equivalency, that's one thing.
Okay.
But if it's a conversion, meaning that they're standard conversions, then you
Right.
don't count your conversions. Like centimeters to grams, you know, or it's not centimeters, centimeters to meters. And so you don't count those, okay? Okay, so does that help? Yes, no, maybe?
Yes.
Yes.
Okay. Clear. Okay, so our next part is temperature. Okay, so in the US, what temperature scale do we use?
Fahrenheit.
So we use Fahrenheit. The rest of the world uses
Celsius.
Celsius. So we need to be able to convert from Fahrenheit to Celsius because we're interacting globally. And as scientists, we have another scale as well too, and that's Kelvin. So I'm going to talk to you about all 3 scales, okay? So if we want to go from Fahrenheit to Celsius, this is the equation, right? So let's say, what is the temperature in Salinas right now?
Right now?
Yep, right now.
63.
63.
Yes.
Okay, so 63 degrees Fahrenheit. Man, it is so cool there. Okay, so let's go ahead and plug that into this equation. So we go 63 minus 32 divided by 1.8. And this is going to give us our temperature in Celsius. What do you guys get?
What's that right next to the T?
This right here, that's degrees Celsius.
Oh, okay. Thank
I
you.
forgot to put the equal sign. So what do you guys get?
It's 45.22222.
Are you sure? 45. Because usually, so 63 minus 32, isn't that like 31 divided by
Yes.
1.8?
$17.222.
17.222. So how many sig figs should I have? So the answer would
2.
So it should be 2 sig figs. So my final answer should be 17 degrees Celsius. Okay, so we know how to go from degrees, or how to go from Fahrenheit to degrees Celsius. Okay, what about going the other way around? Can you guys algebraically change this equation around so that we can solve for degrees Fahrenheit?
Can you repeat that again?
So can you solve for degrees Fahrenheit so that we can actually go the other way? So if we're given Celsius, we can calculate the number of degrees Fahrenheit. So can you change this equation around algebraically?
Oh.
Solving for TF. So I want to say TF is equal to Of course, I erased all of the ones except the one I wanted. Okay, so what would my equation be?
Do you multiply it by 1.8?
So 1.8 times TC
TC plus 32.
Okay.
Do you put the 1.8? So I'm sorry, do you put the TC plus 32 in parentheses or no?
You don't have to because it's one.
The same thing?
Yeah, it's one variable. Yeah. Okay, so let's say we have 100 degrees Celsius, which is the temperature that water boils at. So what is going to be the temperature in Fahrenheit? Oh, actually, let's do 37. So 37 degrees Celsius is the temperature that the ideal temperature that yeast grow at. Okay, so 1.8 times 37 degrees. Plus 32. What does that equal? What do you guys get?
98.6.
Oh, does that sound familiar to anybody? What is your temperature normally?
98.
0.6.
Oh.
Yeah. So yeast love growing on you. Okay, so we can convert to Fahrenheit, right, by maneuvering our equation. So I'm going to give you one more equation. T Kelvin equals T Celsius plus 273.15. Well, and you'll see, sometimes you'll see 0.15 and other times you'll just see 273. Chemists, we get lazy sometimes, but it's really supposed to be 0.15. Okay, so 273.15. Okay, so how can we convert Celsius into Kelvin? And you should probably be asking me, so why do we use Kelvin as chemists? Anybody want to ask? Or does anybody know
Why?
why? So we
No,
use
I don't know.
Kelvin as chemists because Kelvin is the absolute scale. So at 0 degrees Kelvin, molecules stop moving. So, or atoms will stop moving. So you get no movement at all at 0 degrees Kelvin. So that's when life essentially is guaranteed to stop, 0 degrees Kelvin, because you have no movement at all. Okay, so we use that scale because that is like our point. Okay.
Mhm.
Okay, so let's go. So let's go 100 degrees Celsius. How many degrees Kelvin would that be?
Wait, where are you writing?
Right here. You see it at the bottom?
Oh, I see you. Okay, yes, thank you.
You want me to erase all the other stuff so it'll make it a little easier? We'll erase this here. Since we've
Yes,
already done it.
please.
Okay, so if we have 100 degrees Celsius, how many Kelvin is that going to be?
At 273, I'm sorry, 373.15.
Okay, that's correct. So we just put in 100 degrees here. Plus 273.15. Okay, piece of cake?
Yeah.
Okay, so that's temperature. And so 0 degrees Kelvin is absolute zero. You want to kind of keep that in mind because it's going to come up, or you may talk about it. Have you guys there's that movie where the world was totally freezing and they were actually talking about absolute zero. I can't remember the name of it. I think it was like 2099 or something like that. Or
Oh, I know what you're talking about, but I've never seen it.
okay, well, defeats the point then. It's all right. I'll have to remember what it is and put it as on an assignment or something like that. Okay, so this is 3 different scales. We have the Fahrenheit scale, we have the Celsius scale, and we have the Kelvin scale, or the absolute scale. Okay, so you need to kind of be familiar with it because you're going to be playing with temperature throughout the entire semester. Get used to it now, because when we start getting me into it, I don't want to hear, so Dr. Henry, how do I convert Celsius into Kelvin, right? Because you should know that like the back of your hand, right? Speaking of that, let's start with that. Okay, so we have, yes. Someone says, oh. Are we over?
No.
No, we're not. Good.
Actually have to leave for another class in like 2 minutes.
Okay, so yes, we're almost over. But technically we have lab. So we'll run over a little bit and then I have to bolt to that lab class because there'll be somebody waiting for me, guaranteed. Okay, so convert 288 Kelvin to Fahrenheit scale. Okay, so what am I going to do other than look cute? So my TK is going to equal to 288. So what am I going to do? How am I going to convert that to Fahrenheit?
Convert to Celsius first and then go from there to turn to
Okay.
Fahrenheit.
Okay, so how do I convert from Celsius? What was that equation? TK equals,
T Celsius, TC plus 273.
Okay, so I solve for TC, so then I'll have TC equals TK minus 273.
Yeah.
So then I could just plug it in there, plug and chug. So I'll say TC is equal to 288 minus 273. Which is going to equal to what? 14.85?
Yeah.
Okay, so I got 14.85. For Celsius. Now, how do I change that to Fahrenheit?
You're going to multiply that number by 1.8 and then add it.
Okay, I have super hearing, but I did hear it. So I use that equation where I have TF equals 1.8 times TC, and it's plus 32. Okay, so then I plug that into my equation. So I get TF is equal to 1.8 times 14. 14.85 plus 32. And then I get
58.73.
So and if I add round to 2 sig figs, because we do the math and it'll end up being 2 sig figs. So then I'll get 59 degrees Fahrenheit. Piece of cake?
Yes.
Excellent. Okay. Come on. Oops, clear. Okay. So I guess this is going to have to be our stopping point.